today we are going to see the topic matrix. So listen, what do you mean by matrix? A matrix is a rectangular array of elements. It is a rectangular array of elements. So horizontal elements are called to be a row and vertical elements are called to be a column. So consider this as a matrix. So this is called to be the horizontal. So how many rows are there? This is 1 and this is 2. So totally 2 rows. How many rows? 2 rows. Then column is vertical. 1, 2 and 3. So how many columns are there? 3 columns. Column which is equal to 3. So listen once again. A matrix is a rectangular array of elements. Rectangular array of elements. In this, horizontal elements are called to be row. There are 2 horizontal lines. Then vertical is called to be a column. So how many vertical? 3 vertical lines. So column which is equal to 3. Then we are going to see about the order of matrix. So before going to order of the matrix, we must know the general form of a matrix. So general form of the matrix, consider a matrix. So you have to notate the matrix. If you are taking these, you have to notate it in a capital symbol only. So inner values will be a small letter, but notating the matrix, it must be a capital letter, capital alphabet from A to Z, anything. Now I am considering the matrix A, which is of the general form Aij. In this, I denotes the rows and J denotes the column. So consider, now write the form. Now I am going to write the 3 cross 3 matrix. That means 3 rows and 3 columns. So listen, mention the number of rows first, followed by the number of columns. So number of rows is 3, number of columns is also 3. So 3 cross 3 matrix. The general form will be, so write with this. So first row and first column A11. Then first row, second column A12. Then first row, third column A13. Now move to the second row A21. Second row, first column A22. Second row, second column A23. Second row, third column. Now move on to the next row A31. Third row, first column A32. Third row, second column A33. Third row and third column. Third row and third column. Now we will check this order which is similar to this suffix value. If it is same, you have written what correct value. If it is not correct, you have arranged the matrix in wrong order. So listen. So if this is the general form of the matrix, that will be denoted with a capital letter, capital A, which is equal to Aij. So how we have to notate the values? So now I am taking the 3 cross 3 matrix. That means 3 rows and 3 columns. So listen, that will be in the form of, this is called to be first row, second row and third row. First column, second column, third column. Okay. So A11 means the number will mean first row and first column. A12 means first row, second column. A13 means first row and third column. Then A21, second row, first column. A22, second row, second column. A23, second row and third column. Then listen to this. A31 means third row, first column. A32, third row, second column. A33, third row, third column. So this is for 3 cross 3 matrix. If you take 2 cross 2 matrix means, how we can write that? The general form will be A11, first row, first column. A12, first row, second column. A21, second row, first column. A22, second row, second column. So this is for 2 cross 2 matrix. So how you can write this order means, listen here, mention the number of rows first followed by the number of columns. So row must be in first, column must be in second. Okay. So listen to the types. What are the types? Row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, zero matrix, transpose of a matrix, and also triangular matrix, then negative of a matrix. Now listen to the row matrix. What do you mean by row matrix? A matrix is said to be row matrix if it has only one row and any number of columns. So listen once again, a matrix is said to be a row matrix if it has only one row and any number of columns. So listen here. So now check with this. I am taking the example as 8, 5, 2. So this is only one row and 3 columns. So how we can write the order? 1 cross 3. 1 row, 3 columns. So only one row. Which is correct. Only one row and any number of columns. Here we have taken 3 number of columns. So listen, for row matrix, it must be contain only one row. For column matrix, a matrix is said to be a column matrix if it has only one column and any number of rows. Column must be 1 and row must be more than 1. So listen to this example. I have taken this one. So this contains 3 rows and only one column. 3 rows and only one column. So write order for this matrix. 3 rows. So rows must be in first. 3 rows into 1 column. 3 cross 1. So which is a statement. Only one column and any number of rows. Only one column, any number of rows. So difference between row and column is a row. A matrix is said to be a row matrix if it has only one row and any number of column. For column matrix, a matrix is said to be a column matrix if it contains only one column and any number of rows. So then move on to the square matrix. When we say the matrix is a square matrix, a matrix is said to be a square matrix if it has the number of rows which is equal to the number of columns. The number of rows as well as number of columns will be equal. So if you take one example, 3, 1, 2, 1, 5, 4, 6, 3, 1. So this is of order 1, 2, 3. 3 rows in 1, 2, 3. 3 columns. So when the rows and columns must be equal, number of rows and columns are equal, that is called to be a square matrix. So listen to this example. Check with the order. There are 2 rows. It contains 2 rows and 2 columns. So these are order 2 cross 2. These are order 2 cross 2. Where m number of rows which must be equal to number of columns. If it satisfies this condition, this is called to be a square matrix. So listen to the diagonal matrix. So before going the diagonal matrix, you must know the leading diagonal elements. So consider this one. So in this order 3 cross 3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33 is of order 3 cross 3. This A11, A22, A33. These elements are called to be a leading diagonal elements. That elements are called to be a leading diagonal elements. Considering this matrix 3 cross 3. So A11, A22, A33 is called to be a leading diagonal elements. So listen to this 2 cross 2 matrix. This A11, A22 is called to be the leading elements. So listen to the diagonal matrix. So when we say it is a diagonal matrix, means all the elements except those in the leading diagonals are 0. All elements except the, what is the leading elements here? Here this is the leading elements. Except this leading element, all other elements are 0. So excepting that leading diagonals, all others are 0 is called to be a diagonal matrix. Then similar to this scalar matrix. So this is only for square matrix only. We cannot do this for the normal matrix. If you consider this matrix, there is no leading diagonal elements. So this also there is no any leading diagonal elements. So if you want to find the leading diagonal elements, you must take a square matrix. Square matrix means what will you find? The number of rows which is equal to the number of columns. If row and column will be equal, then it is called to be a square matrix. Consider square matrix for diagonal matrix, scalar matrix, identity matrix, zero matrix. For everything, how to take only a square matrix. So in a square matrix, all leading diagonal elements are equal. So in this diagonal elements, we can say only that except the leading diagonals are 0. Except that one are 0. But for the scalar matrix, all leading diagonals are equal. So the leading diagonal must be equal of same number. So listen, the difference between the diagonal and scalar is when you say diagonal element, consider one square matrix. All the elements except the leading diagonals are 0, which is called to be a diagonal matrix. So for scalar matrix, all elements except the leading diagonal elements are 0. But for scalar matrix, consider the square matrix, all leading diagonal elements are equal. The elements must be equal. Now check. For diagonal elements, there is no necessity to be equal. If it is equal also, no problem. But for scalar matrix, you must take all the elements must be, leading diagonal elements must be equal. So we can say the scalar matrix as a diagonal matrix, also a square matrix. This diagonal matrix also called to be a square matrix because these are order 2 cross 2. This is of order 3 cross 3. Number of rows and number of columns are equal. That is called to be a square matrix. Now listen to the next matrix is identity matrix. Identity matrix is otherwise called to be a unit matrix. Identity matrix is otherwise called to be a unit matrix. Why we have saying that one as a unit means the leading diagonals are 1, rest are 0. The diagonal elements, the leading diagonal elements must be 1. The leading diagonal elements must be 1. All others are 0. So listen, this matrix is of order 2 cross 2. So we can say this identity matrix as a square matrix, diagonal matrix, scalar matrix and also a unit matrix. So what do you mean by identity matrix? Means a matrix is considered a square matrix. A matrix is said to be a unit matrix means the leading diagonal elements are 1, rest are 0. Leading diagonal elements are 1, rest are 0. So considering this 2 cross 2 matrix, except the leading diagonal, others are 0. You can notate this as an I. It is of order 2, so I can put 2. So listen to the next matrix is 0 matrix. For 0 matrix, take one square matrix. In this, all elements are 0. So square matrix, in this, all the elements are 0. So I am taking the 2 cross 2 matrix. All the elements are 0. Then this matrix is called to be 0 matrix, which is equal to 0. So we can say this as a 0 matrix or otherwise called to be a null matrix. Then listen to the next matrix is transpose of a matrix. Transpose means you have to transfer. That means interchanging the elements in rows and column. Interchanging the elements in rows and column is called to be a transpose of a matrix. Now I am taking one matrix A which is equal to 1, 5, 8, 9, 4, 3. So how many rows are there? There are 3 rows and 2 columns. There are 3 rows and 2 columns. Now how to transfer the elements? So columns must be changed into row and rows must be changed into a column. So first of all, taking this column and it will be written as in a row. So 184 will be changed as 184. Then this 593 will be changed and written as 593. So column is interchanging into row and row it is interchanging into column. So that is called to be a transpose of the matrix. A transpose the whole transpose which is similar to that same A. So A, you are finding out A transpose. Now you are going to transfer that also means this row will be changed as column as 1, 8, 4 and these row also changed into column 5, 9, 3. So again if you are taking A transpose the whole transpose, again you take the similar way for the value for the A. So transpose matrix is nothing but interchanging the elements in a row and columns. Interchanging the elements in a rows and columns. For example, if you are taking these elements means this column must be interchanged into row. These two columns must be interchanged into row. Again you are taking transpose for this. This row will be changed into a column. So A transpose the whole transpose which mean by A. So listen once again what we have learned in this previous sessions means. First of all we learn what is matrix. A matrix is a rectangular arrangement of elements. In this rectangular arrangement of elements, the horizontal elements are called to be a row and vertical elements are called to be a column. So listen here. Then order of the matrix. How you find the order of the matrix? That is the number of rows into columns. Rows must be set in a first, then you have to write the column. Then listen to the types. First type is row matrix. A matrix is said to be a row matrix if it has only one row and any number of columns. Only one row and any number of columns. What do you mean by column matrix? A matrix is said to be column matrix if it has only one column and any number of rows. Only one column and any number of rows. Here only one column and 3 rows. Next, square matrix. A matrix is said to be a square matrix if number of rows and number of columns are equal. That means both row as well as column will be a same. Then move on to the diagonal matrix. So before this diagonal matrix, you must know the leading diagonal elements. That is came from the general format that A11, A22, A33 is called to be a leading diagonal elements. So except those leading diagonals are 0. Except that those leading diagonals, others will be 0. Is called to be a leading diagonal matrix. Then scalar matrix. All leading diagonal elements are equal. Whether you are writing the leading diagonal element, all must be equal. Then for the identity matrix, leading diagonal are 1, rest are 0. The diagonal elements will be 1, others must be 0. For 0 matrix, all elements must be 0. Transfer of a matrix. Interchanging the rows into columns and columns into rows is called to be a transpose of a matrix. Now we are going to see the next matrix is triangular matrix. So listen here, the entries above the leading diagonals are 0. Entry above the leading diagonals, above means this is. So this is called to be triangle. Entries above the diagonals are 0, which is called to be the lower triangular matrix. The entries below the leading diagonals are 0, it is called to be a upper triangular matrix. Entries above the leading diagonals are 0. Entry above the leading diagonals are 0 is called to be a lower triangular matrix. Entries below the leading diagonals are 0. Entries below the leading diagonals are 0, which is called to be a upper triangular matrix. So these are the two variations in the triangular matrix. The next one is equal matrix. Each element of A is equal to the corresponding elements of B. So check. For example, I am taking A which is equal to A, B, C, D. So what is the order for this matrix? Order for this matrix is 2 cross 2. 2 rows and 2 columns. Then look at the matrix B. These are also of order 2 rows and 2 columns. So both matrix will be called to be equal matrix. The rows and column of both A and B matrix are same. Then the matrix is called to be a equal matrix. Then negative of a matrix. Replacing each element in matrix with its additive inverse. Replacing each and every element with its additive inverse is called to be a negative of a matrix. For example, now I am considering the matrix C. 2 minus 4, 5 minus 3. So for each and every element in this matrix C will get additive inverse. Additive inverse means you have to change. For 1, additive inverse is minus 1. Then only both gets equal to 0. So for 2, what is the additive inverse? Minus 2. For 5, minus 5. Minus 4 plus 4 gets 0. So minus 3 plus 3. Additive inverse you have to change. For each and every element in the matrix, you have to change the additive inverse. That one is called to be a negative of a matrix. So listen once again. Here triangular matrix, equal matrix and negative of the matrix. What do you mean by triangular matrix? Entries above the leading diagonals are 0, which is called to be a lower triangular matrix. Entries above the leading diagonals are 0 is called to be a lower triangular matrix because which is in the form of triangle. Entries below the leading diagonals are 0. Entries below the leading diagonals are 0 is called to be an upper triangular matrix. Then equal matrix. You can consider any of the two matrix is of equal order. That is called to be an equal matrix. Then negative of the matrix, you can write the negative value for each and every element. Okay. Then listen to the first problem. Exercise number 3.17. What is exercise number 3.17? Look to your book. In the matrix A, which is equal to 8, 9, 4, 3, minus 1, root 7, root 3 by 2, 5, 1, 4, 3, 0, 6, 8, minus 11, 1. Write the number of elements, order of the matrix. Write the elements corresponding to A22, A23, A24, A34, A43 and A44. Look at here. Now take the given matrix. What is our matrix? A, which is equal to 8, 9, 4, 3, minus 1, root 7, root 3 by 2, 5, 1, 4, 3, 0, 6, 8, minus 11, 1. So here first what you want to find? You want to find the number of elements in the given matrix. So you have to count each and every element of the matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So how many elements? 16. In this way you can find out, or else you have to find using the order. So what is the order for this matrix? First you calculate the number of rows. 1, 2, 3 and finally 4. 4 rows into 1, 2, 3 and 4. 4 columns. So 4 cross 4. So 4 4s are how much? 16. So elements in the matrix 16. So you can write the order. What is the order? 4 cross 4. Then listen, how to find out the value for A22, A23, A24, A34, A43, A44. So how you find out these values? Already we saw for the 2 cross 2 matrix, you can write A11, A12, A21, A22. So the similar way you can write for this also. So in above you can write A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, A41, A42, A43, A44. So find out A22. That means second row and second column. Second row and second column. What is the value? A22 value is root 7. Then A23. That means second row and third column. Second row and third column, our value is root 3 by 2. A22 is second row and second column, that is root 7. A23 means second row and third column, the value is root 3 by 2. Then next value 8, 2, 4. That means second row, fourth column. Second row, fourth column. What is the value? That is 5. Then A, 3, 4. Third row, fourth column. Third row, fourth column. The value is 0. Then A, 4, 3. Fourth row, third column. The value is -11. A, 4, 4. Fourth row, fourth column. The value is 1. So listen. First you have to find the number of elements using the given matrix A. So you have to total the value or else find order. Afterwards you can multiply and write the number of elements in the matrix. Then for finding the order of the matrix, first you have to count how many numbers of rows and multiply by number of columns. Then values means you have to write the general format and then you can calculate the value. A22 is second row, second column value √7. A23 is second row, third column √3/2. Then A24 is second row, fourth column value is 5. A34 is third row, fourth column value is 0. Then A43 is fourth row, third column value is -11. A44 means fourth row, fourth column value is 1. So next, listen to the book. Second question. If a matrix has 18 elements, what are the possible order it can have? What if it has 6 elements? If your matrix has 18 elements, suppose one matrix, here we consider the matrix with 16 elements. So for that, if you had 18 elements matrix, what are the possible orders? What are the possible orders it will have? And you have to find it. If it has 6 elements, what order it will contain. Okay. So next, write the given statement. The matrix has 18 elements. So if the matrix contains 18 elements, the possible orders are. So 18 comes in 1 cross 8. Then 18 cross 1. Then 2 into 9 is also 18. 9 into 2 also 18. 3 into 6 is 18. 6 into 3 is also 18. So if the matrix contains 18 elements, the possible orders are 1 into 18, 18 into 1, 2 into 9, 9 into 2, 3 into 6 and 6 into 3. Then if the matrix has 6 elements, the orders will be. So 6 comes in which table? 1 into 6, 6 into 1, 2 into 3 and also 3 into 2. So if matrix has 6 elements, the possible orders are 1 cross 6, 6 cross 1, 2 cross 3 and 3 cross 2. So listen this question once again. If a matrix has 18 elements, what are the possible orders it can have? What if it has 6 elements? So if the matrix has 18 elements, the possible orders are 1 into 18, 18 into 1, 2 into 9, 9 into 2, 3 into 6 and 6 into 3. So if the matrix has only a 6 element, then its order will be 1 cross 6, 6 cross 1, 2 cross 3, at last 3 cross 2. Then listen to the third question. Construct a 3 cross 3 matrix whose elements are given by. So now you take one 3 cross 3 matrix. So you have to find two solutions for that. Aij which is equal to modulus I minus 2j and second one Aij which is equal to I plus j power 3 by 3. So listen, consider one 3 cross 3 matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33 is of order 3 cross 3. So apply into this format. Here I is row, J is column. So A11 means I rows and I columns. 1 rows and 1 column. 1 plus 1 whole power 3 divided by 3. So 1 plus 1 is 2. 2 power 3 is 8. So 8 divided by 3. Second element, second row, first column. So 2 plus 1 whole power 3 divided by 3. 2 plus 1 is 3 power 3 by 3. 3 power 3 is 27 by 3. Now you cancel in those to get the value as 9. Then listen. Third row, first column. So 3 plus 1 whole power 3 by 3. 3 plus 1 is 4 power 3. 4 power 3 is what? 4 fours are 16. 16 into 4. 6 fours are 24. Balance 2. 64. So 64 by 3. Here you cannot cancel this value. So next A12. A12 means first row, second column. 1 plus 2 whole power 3 by 3. 1 plus 2 is 3. 3 power 3 by 3. What is 3 power 3? 3 power 3 is 27. 3 into 3 9. 9 3s are 27. 27 by 3. Cancelling those values can get the value as 9. 9 3s are 27. Next A22. Second row, second column. So 2 plus 2 whole power 3 divided by 3. 2 plus 2 is 4. 4 power 3 divided by 3. So 4 power 3 is already what? 64. 64 by 3. These two numbers didn't get cancelled. So move on to the next value. I have written A23 here. So second row, third column. A23 which is equal to 2 plus 3 whole power 3 divided by 3. 2 plus 3 is 5. 5 cube by 3. What is 5 cube? 5 5s are 25. 25 into 5 which is equal to 125. So what is the value for this? 125 by 3. So here also we didn't get cancelled. So next move on to the next one. A13. A13 is first column what? First row, third column. First row, third column. What is the first row, third column? 1 plus 3 whole power 3 divided by 3. 1 plus 3 is 4 power 3. 4 power 3 written as 64 by 3. Then next A33. A33 is what? 3 plus 3 whole power 3 divided by 3. Then 3 plus 3 is 6. 6 divided by 3. So 6 power 3 is 6 6 are 36. 36 into 6. 6 6 are 36. Balance 3. 3 6 are 18. 21. 216 divided by 3. Now you cancel this. 3 7s are 21. This comes as 2 times. So next one is A32. A32 is what? 3 plus 2 by 3. 3 plus 2 is 5. 5 power 3 by 3. 5 power 3 is what? 5 power 3 is 125. 125 by 3. So listen once again how to write, find each and every value. A11, A12, A13, A21, A22, A23, A31, A32, A33. So you can find each and every value. What is the value for A11? A11 value is 8 by 3. So you have to substitute here. 8 by 3. A21 is what? 9. A21. So here you put 9. A31. What is our A31? 64 by 3. So A31 is 64 by 3. Next A12. What is A12? A12 is 9. Next A22. A22 64 by 3. Then A32. What is our A32? 125 by 3. Then A13. A13 is 64 by 3. Next A23. What is our A23? A23 is 125 by 3. Then A33 is 72. So this is our final answer. So construct a 3 cross 3 matrix. So we have already constructed the 3 cross 3 matrix. They given one format Aij which is equal to I plus j whole power 3 divided by 3. So we have to apply for each and every term. A11, A21, A31, A12, A22, A32, A31, A23, A33. So after finding the values, you have to substitute the matrix. These are the form 3 cross 3. Okay. Everybody look at the page number 144, fifth problem. If A which is equal to root 7 minus root 5 minus root 3 minus 3 2 minus 5. Then find the transpose of minus A. So listen, given one matrix A which is equal to root 7 minus root 5 root 3 minus 3 2 minus 5. For this, how to find which one? Minus A transpose. So in the theoretical part, transpose of the matrix which is equal to, that means what? Interchanging rows into columns. This rows will be interchanged into columns. This columns will get interchanged as a row. So here they ask you minus A transpose. So first you have to find minus A, then you have to transpose that minus A. So minus A means negative of A. So what is the statement for the negative of the matrix? The negative of the matrix is nothing but find the additive inverse for each of the every element. So root 7, its additive inverse is minus root 7. For minus 5 plus 5, root 3 minus root 3, minus 3 plus 3, 2 minus 2, minus 5 plus 5. This is the negative of A. Then, now you find the minus A transpose. So, in this minus A, rows and columns will be get interchanged. So, this is the column that gets interchanged as the row. This minus root 7, root 5, minus 3 will be written as a row. Then next this 3 minus 2, 5 will be written as another row. This column will be written as another row. 3 minus 2, 5. So listen, transpose is interchanging of rows and column. Here they ask you to find minus A transpose. So for that, before you have to find minus A. Minus A is nothing but the negative of the given matrix. So for negative of the matrix, you have to find the additive inverse. So here root 7 is minus root 7, minus root 5 is positive 5, positive root 3 is negative root 3, and minus 3 plus 3, 2 minus 2, minus 5 plus 5. Now you have to find minus A the transpose. So the rows, both rows will be changed as a column and columns will be changed as a rows. So now take this first column and second column. First column will be changed as row and second column changed as second row. Minus root 7, 5 minus root 3 will be taken here, and this second column 3 minus 2, 5 will be written as a second row. Then listen to the sixth question, page number 144. If A which is equal to 5, 2, 2 minus root 17, 0.5, 5 by 2, 8, 3, 1. You have to verify A transpose the whole transpose which is equal to A or not. So they asked you to find A transpose the whole transpose which is equal to A. This one you have to prove. So for that, first take that A. So write the A value 5, 2, 2 minus root 17, 0.75 by 2, 8, 3, 1. So find transpose. Transpose means what? Now changing the rows into columns and columns into rows. So first take this column 5 root 17, 8. This will be written as a row. 5 root 17, 8. And take the next column. What is the next column? 2, 0.7, 3. So the second column will be written as second row. 2, 0.7, 3. Next, what is the third column? 2, 5 by 2, 1. This column will be interchanged and written as next row. 2, 5 by 2, 1. So both three columns get interchanged as a row. Now you have to find A transpose the whole transpose. A transpose we have find out. Next A transpose the whole transpose. So A transpose the whole transpose means in this also these column. First column changed into a first row. 5, 2, 2. First column will be changed as a row. 5, 2, 2. Then next this minus root 17, 0.75 by 2. Second column will be written as second 0.7 5 by 2. So next last column 8 3 1, that can be rewritten as 8 3 1. This column will be rewritten as next row. So interchanging of rows and columns is nothing but the A transverse. Okay. So listen to this. A transverse, the whole transverse equal to A or not. So listen to the both terms. 5 2 2. 5 2 2. Root minus root 17 0.75 by 2. Minus root 17 0.75 by 2. 8 3 1. 8 3 1. Take this as 1 second. So comparing the 1 and 2, we get A which is equal to A transverse the whole transverse, hence the proof. So keeping in mind the theoretical part, we can do this problems easily. So each and every problem you can remind the theoretical part. What the given matrix, what you have to find. Okay. So next to move on to the next problem, that is 7th problem. Look at the page number 144, 7th problem. Listen to the 7th problem. Find the value of x, y and z from the following equations. So check with the first question. 12 3 x 5 which is equal to y z 3 5. So check with the first question. 12 3 x 5 which is equal to y z 3 5. In this given matrix, you have to find the x and y values. So equating the both matrices. So check with this. What is this? A11, A12, A21, A22. Likewise, here also you check. This is 2 cross 2 matrix. And check here also. A11, A12, A21, A22. So this is of order 2 cross 2 matrix. So both are 2 cross 2 matrix. You can equate and find out the value. So this x is what? A21. So what is the A21 value here? 3. So x which is equal to 3. Likewise you have to find the y and z value. So what is our y? Our y is A11. So compare with here. So what is our A11? Our A11 is 11. Then z is A12. Compare with these matrix. What is A12? Our A12 is 3. Okay. So if they given you some matrix with the variables x, y, z or a, b, c, you can compare the two matrices. First check is of a same order or not. Then compare the equations and find out the values. So listen to this. This is also A11, A12, A21, A22. Compare with this. This is of order 2 cross 2. Next matrix is A11, A12, A22, A23. This is also of order A21, A22. These are of order 2 cross 2. Both the matrices are of order 2 cross 2. Then you can equate the values. So first equate the A11, x plus y which is equal to 6. Write the equation x plus y which is equal to 6. Then consider this A22 which is equal to A22. xy which is equal to 8. xy which is equal to 8. At last A21, 5 plus z which is equal to 5. From this we can find the z value. 5 plus z which is equal to 5. You take this positive 5 to that side means it gets negative. 5 minus 5 is 0. Our z value is 0. So now we have found out one value. Then listen to the next. From the second we can write. We need only y means x comes to the denominator side. Y which is equal to 8 by x. Y which is equal to 8 by x. Now substituting this y value in the first equation. What is our first equation? X plus y which is equal to 6. So instead of that y, we can put the value 8 by x. So x plus 8 by x which is equal to 6. Cross multiplying this, we can get x square plus 8 by x which is equal to 6. So you can cross multiply this x to this side. X square plus 8 which is equal to 6x. So take this x also to this side means, so it will be changed. X square minus 6x plus 8 which is equal to 0. If If you multiply any of numbers, you get the value 8, and if you add or subtract that number, you will get the value as 6. So which is negative 6. So negative 6 means minus 4 minus 2. Then only you get both values are added and get minus 6. Both get multiple. Minus into minus plus 4 2s are 8. So these 6x can be replaced and written as 4x minus 2x. So x square minus 4x minus 2x plus 8 which is equal to 0. Take x as common. Other terms are x minus 4. From these two terms you can take 2 as common. X minus 4 which is equal to 0. X minus 4 are common. You can take x minus 2 which is equal to 0. So from this we can write x minus 4 which is equal to 0 and also x minus 2 which is equal to 0. So you get the value as x which is equal to 4. Substitute x equal to 4 in this. So if you are substituting x equal to 4 in this, 8 by 4 which is equal to 2. If you substitute x instead of x 4 in this value, y which is equal to 8 by 4, 8 by 4 is 2. Then if you substitute x minus 2 which is equal to 0, then x equal to 2. Substitute here x equal to 2 means this y changed as 8 by 2. So cancelling those values you get the value 4. If x equal to 4, y equal to 2. If x equal to 2, y equal to 4. So that's our solution. Z equal to 0. If x equal to 4, y equal to 2. If x is 2, y equal to 4. So for this problem, finding values for x, y is that you have to check the order will be same or not. Then equating the values you can find easily. So listen once again. Today we saw about the matrices. So what do you mean by matrix? A matrix is a rectangular arrangement of elements. The horizontal arrangement is called to be row and vertical arrangement is called to be a column. Then its type. What are the types? First type is row matrix. A row matrix is nothing but it contains only one row. A matrix which contains only one row and any number of columns is called to be a row matrix. And then column matrix is nothing but a matrix, it contains only one column and any number of rows. So then if you said it is a square matrix means both number of columns and number of rows will be equal. Diagonal matrix. Except that leading diagonal, other elements will be 0. For scalar matrix, the leading diagonal value will be equal, other elements must be 0. For unit matrix, the leading diagonal elements will be 1, others will be 0. Then for the 0 matrix, each and every element will be 0. What do you mean by transpose of a matrix? Interchanging of rows and columns into rows is called to be a transpose of the matrix. Then we saw the triangular matrix that has two types, upper triangle and lower triangle. For lower triangle, the entries above the leading diagonals are 0. Entries above the leading diagonals are 0 is called to be a lower triangular matrix. Upper triangle matrix below the leading diagonal elements are 0 is called to be a upper triangle matrix. After that we saw the equal matrix. Consider two matrix is of order same, then it is called to be a equal matrix. Negative of the matrix is how to find the additive inverse for each and every element of the given matrix. So thank you children.